In 1971, a blue whale washed ashore in the Azores with dozens of circular wounds carved into its flank, each one identical, each one the exact diameter of a golf ball. That same year, 6,000 miles away, the USS Dorado sat in dry dock at Pearl Harbor. Maintenance crews found 19 circular penetrations cored through the rubber coating that protected its sonar array. Each hole measured 5 centimeters across, each one punched cleanly through 3 centimeters of neoprene. Naval intelligence classified the damage as possible sabotage. The investigation ran 6 weeks. They searched for a person with tools, access, and a reason to compromise a nuclear submarine. They never found one. A marine biologist named Sheldon Gruber matched the bite pattern. The perpetrator the Navy had been hunting weighed less than 400 grams, less than a can of soup. Inspection of 12 additional submarines in the Pacific Fleet revealed the same damage on 8 vessels. The acoustic degradation reduced passive sonar range by up to 22%. A fish smaller than a human forearm had compromised the hearing of the United States nuclear submarine fleet. But the damage assessment was not the disturbing part. The disturbing part came 18 months later. The Navy's solution was to coat sonar domes with fiberglass, harder material, higher abrasion resistance. Within 18 months, cookie cutter bites were found penetrating the fiberglass layer. The sharks had adapted their targeting to the new material. The creature responsible is called Isosteus brasiliensis. Common name, the cookie cutter shark. Maximum recorded length, 56 centimeters for a female, 42 for a male. Body shape, elongated cigar, nearly cylindrical, dark chocolate brown. Total body weight, 150 to 450 grams. It lives at 3,700 meters depth. Pressure at that depth, 370 atmospheres, 5,400 psi. No light has ever reached that depth in any ocean. Every night it ascends. 3,000 meters of vertical migration, rising at approximately 200 meters per hour through featureless black water. It arrives at the surface between 2000 and 2200 local time. It feeds. It descends before dawn at 300 meters per hour. It does not live at the surface. It does not live at a reef. It commutes. The deep scattering layer rises with it. A 200-meter thick living blanket of lanternfish, hatchetfish, and bristlemouths that migrates through the water column together. This layer is so dense it was misidentified as the ocean floor by early sonar systems. The cookie cutter shark rides inside it the way a commuter rides a train. Its liver occupies 35% of its body cavity by volume, saturated with low-density squalene, providing near-neutral buoyancy. Its metabolic rate runs approximately 40% lower than comparably sized sharks. The 6,000-meter daily round trip demands conservation, and this animal is built for the commute. The feeding mechanism operates in 3 stages. Stage 1, the lips, thick, fleshy, suctorial. They function as a suction cup generating an estimated 0.4 atmospheres of negative pressure against the target surface. The seal forms in 0.3 seconds. Once suction is established, the target cannot dislodge the shark without tearing its own tissue. Stage 2, the upper jaw. 30 to 37 narrow, erect teeth that function as anchor hooks. They do not cut, they hold. Stage 3, the lower jaw. 25 to 31 triangular teeth fused at the base into a single bandsaw-like cutting unit. The entire lower dental band operates as one rotary blade. The shark rotates its body 360 degrees at an estimated 2 to 3 revolutions per second. Tangential cutting force, 18 to 22 newtons along the cutting edge. The result is a clean cylindrical core of tissue, 5 centimeters in diameter, 7 centimeters deep, identical in geometry to an industrial hole saw sample. Total operation time from attachment to extraction, 1.8 to 2.2 seconds. The The ventral surface of this shark produces green bioluminescence at a wavelength of 485 to 500 nanometers. This matches the ambient downwelling light in mesopelagic waters. From below, the shark has no silhouette. It is invisible, except for one patch, a dark collar band around the throat, no denticles, smooth skin. This band does not glow. Against the illuminated belly, it appears as a small dark fish shape. Prey approaches from below to eat what it perceives as a small fish. It is bitten by an invisible mouth. The shark uses camouflage and lure simultaneously. It disappears everything except the part designed to attract attention. The first protocol conclusion from the Navy investigation. Engineering countermeasures against this feeding system have a limited operational lifespan. Neoprene was penetrated immediately. Fiberglass was penetrated within 18 months. 8 of 12 Pacific Fleet submarines carried damage before anyone identified the source. If the United States Navy could not prevent a 400-gram fish from degrading nuclear submarine sonar capability, the question becomes very specific. What does this feeding mechanism do to human tissue? The creature does not distinguish between a nuclear submarine and a long-distance swimmer. Both are surfaces, both are warm, both generate electromagnetic signatures, both receive a 5-centimeter hole. March 2009, Alenuihaha Channel, between Maui and the Big Island of Hawaii. Long-distance swimmer Mike Spalding enters the water at 19:15 for a guided channel crossing. Escort kayakers maintain 3-meter distance. Chemical light sticks mark the route. Protocol note: artificial light sources in open ocean attract Isosteus brasiliensis. Chemical light sticks, vessel deck lights, and underwater illumination create aggregation points. Spalding's escort team was using chemical light sticks. At approximately 21:30, 14.2 kilometers from shore, Spalding reported a sudden suction sensation on his left calf, followed by sharp pain. He described the initial contact as, quote, like someone pressed a toilet plunger against my leg and twisted. Upon extraction from the water, the wound measured 7 centimeters in diameter and 4 centimeters deep. A clean cylindrical plug of tissue removed from the gastrocnemius muscle. No fragment of tooth material remained in the wound. Emergency medical treatment at Hilo Medical Center required 28 sutures and 3 weeks of wound care. The attending physician initially suspected a surgical instrument. The wound edges were that clean. But the wound was not the most significant data point from this incident. Spalding was wearing a blood glucose monitor on his opposite arm. The monitor recorded a glucose spike at 21:28, 2 minutes before he felt the bite. His body detected the electrical disturbance of the shark's approach before his nervous system registered the tissue removal. The autonomic stress response activated before conscious awareness. His own biology knew something was coming. He did not. November 2019, Oahu, Hawaii. Endurance athlete Eric Norrie is night swim training for an upcoming Ironman event. Approximately 400 meters offshore. Water depth exceeding 60 meters. Time approximately 21:45. Same island chain. Same hour. 10 years later, Norrie felt what he described as a plunger being pressed into his leg and ripped away. The sensation lasted less than 2 seconds. His immediate assumption: a jellyfish sting. He continued swimming for approximately 45 seconds before reaching his escort kayak and noticing blood. Emergency room staff asked if he had been injured by a boat propeller. The wound did not look like a bite. 5 centimeters in diameter. Clean, circular extraction from his lower left leg. The specific detail Norrie remembers above all others is the sound. A small wet pop, like pulling a suction cup off glass, audible even underwater. That was the sound of pressure equalization as the tissue plug separated from his leg. Norrie no longer swims in open water after sunset. His reasoning is not emotional, it is mathematical. If you swim at night in deep water, the question is not whether they are there. They are always there. The only question is whether tonight is the night one of them selects you. Dr. Jeanette Winnikin at Florida Atlantic University has dissected over 40 Isosteus specimens obtained from deepwater longline bycatch. Her laboratory quantified the rotational mechanics of the lower jaw. The tooth band operates at an estimated 2.4 revolutions per second. Her assessment of the feeding apparatus. The engineering is redundant. 3 independent mechanisms, any one of which would work alone. The suction, the anchoring, the rotation. Together, they create a system with no identifiable failure mode. She redesigned her specimen handling protocol after a freshly dead cookie-cutter shark bit through a double-layer nitrile glove during jaw measurement. Cardiac arrest had been confirmed. Post-mortem reflex. She now uses steel mesh cut-resistant gloves for all Isosteus dissection. The creature bites after it is dead. No defensive posture change. Purely aggressive oral response even in terminal distress. The protocol established so far assumes a principle. Avoid the surface at night in tropical waters, and you reduce encounter probability. Between 2000 and 0400 local time in waters between 20 degrees north and 20 degrees south, assume cookie-cutter sharks are present in the upper 200 meters. This assumption was wrong. 2019, NOAA research vessel Oscar Elton set. Station Aloha 100 kilometers north of Oahu. Midnight acoustic survey using the Deep Argo float program. At 23:47 and 3 seconds, hull-mounted hydrophones recorded a series of rhythmic impact sounds. Small, wet, percussive. One impact every 4.2 seconds, consistent for 11 minutes. Deck crew observed 12 to 15 small sharks circling the vessel's waterline lights, approaching and retreating in irregular patterns. 3 crew members observed individual sharks attaching to the hull below the waterline, their bodies visibly rotating before detaching. Morning inspection revealed 7 fresh, circular marks on the anti-fouling paint, 2 of which had penetrated to bare steel. That paint was rated to resist 8 years of marine fouling. The cookie-cutter sharks removed it in 2-second intervals. But the surface attack was not the significant finding from this incident. The hydrophone array was deployed at 450 meters depth. Simultaneously with the surface impacts, it recorded a second cluster of identical sounds, same rhythm, same percussive signature, 450 meters below the vessel. Cookie-cutter sharks were attacking both the surface vessel and the deep-water instrument package at the same time, 450 meters apart. The population column extends continuously through the water. There is no safe depth. The protocol assumption that avoiding the upper 200 meters reduces risk is incomplete. The threat occupies the entire column from the surface to 3,700 meters. 2023, Monterey Bay Aquarium Research Institute, Doc Ricketts ROV, 980 meters depth in Monterey Canyon. During a benthic survey of the canyon's oxygen minimum zone, the ROV's 4K camera recorded a solitary cookie-cutter shark hovering at 978 meters, stationary, ventral surface glowing vivid green against total darkness. The shark maintained this position for 47 minutes without visible locomotion, metabolic conservation mode during daytime. At 16:23 and 41 seconds, pilot Lisa Munger extended the ROV's manipulator arm toward a sediment sample 2.8 meters from the shark. The shark rotated 90 degrees to face the arm, tracking the hydraulic actuator's movement. When the arm retracted, the shark followed, exactly 2.8 meters, constant distance. Munger adjusted the ROV's thrusters to create a 0.3 knot current. The shark compensated instantly, holding station relative to the manipulator arm. Not the ROV body, the arm specifically. It tracked one component of a complex machine for 6 minutes, distinguishing the manipulator's electrical signature from the main thruster motors at 2.8 meters distance. When Munger powered down the manipulator arm's hydraulic pump, the shark lost interest within 8 seconds, resumed its stationary hover. It was not tracking movement. It was tracking the electromagnetic fields generated by the pump motor. It could distinguish between 2 different motors on the same vehicle from nearly 3 meters away. Protocol update. Electrical shark deterrent devices, marketed to divers and swimmers, generate electromagnetic fields designed to repel large sharks. Isosteus brasiliensis is attracted to electromagnetic fields. The device intended to protect you becomes a beacon. The thing designed to save you calls it closer. Dr. Jeanette Winneken's mechanical assessment of the feeding system identified 3 independent mechanisms with no failure mode. But the system's reliability extends beyond mechanics. The entire lower tooth band, 25 to 31 fused teeth, is shed as a single unit every 15 to 20 days. The shark swallows it whole. Estimated calcium recovery: 60 to 75% of mineral content reabsorbed through the gut. A 2019 isotope analysis by Duchâtelet and colleagues revealed that recycled calcium integrates into new tooth formation within 72 hours of ingestion, faster than dietary calcium absorption from prey. At a replacement cycle of 15 to 20 days, a single shark swallows approximately 18 to 24 complete tooth sets per year. No other shark recycles its teeth. Isosteus has built a closed-loop manufacturing system for cutting tools, independent of dietary calcium intake. It recycles its own blades. Dr. Julien Claes at the Université Catholique de Louvain in Belgium is one of fewer than 10 researchers worldwide focused primarily on Isosteus bioluminescence. His laboratory has documented that cookie-cutter shark photophores produce light for up to 3 hours after death, the longest documented post-death bioluminescence of any vertebrate. His current hypothesis: the bioluminescent system is not neurally controlled. It is hormonally mediated through melatonin and prolactin pathways. This explains why it persists after brain death. The shark glows on a lab bench for 3 hours after cardiac arrest. The frustration of studying this species is fundamental. It cannot be kept in captivity. Every attempt has resulted in death within 24 to 48 hours. Aquarium specimens cease feeding, lose bioluminescence within 6 hours, expire from what appears to be pressure-related organ failure, despite gradual decompression protocols. Fewer than 30 individuals have been successfully tagged as of 2023. Deep phase behavior between 1,000 and 3,700 meters remains almost entirely unobserved. Dr. Claes described his work in a way that reframes the entire field. We understand this animal primarily through its bite marks, its stomach contents, and its corpse. The living animal at depth, its behavior, its social interactions, its decision-making, remains almost entirely theoretical. We study the evidence it leaves behind. Like forensic investigators at a crime scene where the perpetrator is 3 kilometers below us and returning tomorrow night. Consolidated protocol between 2000 and 0400 local time in tropical oceanic waters, 20 degrees north to 20 degrees south latitude. Assume cookie-cutter sharks are present, not just at the surface, through the entire water column. Artificial light sources attract them. Electrical deterrent devices attract them. Neoprene wetsuits of standard diving thickness, 3 to 7 millimeters, offer zero protection. The rotational cutting mechanism has been demonstrated to penetrate 3.2 centimeters of neoprene on submarine sonar domes, In 100% of documented human encounters, the victim did not detect the approach. Counter-illumination eliminates the visual silhouette. The approach vector is from below and slightly behind. Standard scan-the-water protocols are ineffective against this species. There is no confirmed method to detect a cookie-cutter shark's approach in open water at night. The animal is invisible from below. Silent. Closes distance in seconds. No existing technology provides reliable, real-time warning. The current protocol gap is total. Isosteus brasiliensis has been making this commute for approximately 35 million years based on the fossil record. 35 million years. When this species began its nightly ascent, there were no humans. Human existence spans roughly 200,000 years. This commute predates our entire species by a factor of 175, every night for 35 million years. 3 kilometers up, feed. 3 kilometers down. In 2022, a study by Viegas and colleagues in the Azores detected Isosteus brasiliensis eDNA in surface water samples. Taken during daylight hours, when the sharks should be at 1,000 to 3,000 meters depth, the concentrations were low but consistent across 14 sampling stations. 2 explanations exist. Either the sharks shed DNA that persists at the surface for more than 12 hours after they descend, or some individuals are not descending at dawn. If a subset of the population has abandoned the migration pattern and remains at the surface permanently, they would be functionally invisible. Their counter-illumination system matches ambient downwelling light. It works in daylight too, not just at night, at all times. The protocol framework from all 4 incidents. Night swimming in tropical deep water is high risk. Lights attract this species. Electrical deterrents attract this species. Neoprene does not stop this species. Detection is currently impossible. The damage-to-body mass ratio of Isosteus brasiliensis exceeds any other living shark by a factor of approximately 200. The most dangerous cognitive error when encountering this species is size dismissal. A diver who would exit the water for a 1.5-meter reef shark remains in the water with an animal that has attacked nuclear submarines. Documented prey includes blue whales, sperm whales, orcas, great white sharks, yellowfin tuna, swordfish, dolphins, elephant seals, and United States Navy submarines. Some whales carry 30 or more cookie-cutter scars simultaneously. Great white sharks carry cookie-cutter scars. Nuclear submarines carry cookie-cutter scars. Every other dangerous marine animal occupies a territory you can choose to avoid. Do not enter reef shark territory. Do not swim near crocodile estuaries. Do not touch box jellyfish. The cookie-cutter shark does not occupy a territory you can avoid. It occupies all tropical ocean surface water, but only at night, or maybe not only at night. It does not hunt you. It commutes to you. This report documents an organism that executes a 6,000-meter daily round trip to feed on surfaces larger than itself. Subsequent documentation covers organisms that do not commute. They wait, access pending authorization. Between 2000 and 2200 local time tonight, in every tropical ocean on Earth, the commute is underway. 3 kilometers below the nearest warm surface, something weighing less than a can of soup is ascending. It does not know what it will find at the top. It has never needed to.